Welcome, everybody. As you've probably heard, Microsoft did an announcement of a breach by Midnight Blizzard, and Andy did some analysis of kind of how that breach may have occurred. There's maybe some speculation based on the information that Microsoft was able to share. Andy's able to use some of his experience with how the intra ID permissions and different structure works, and he wants to kind of talk about how that played out, or how it may have played out. There was he wrote up some information about how he thinks it may have worked on Twitter, and got quite a few different requests to kind of go into more detail for those of us that maybe only have experience on the AD side, on the on-prem AD side. And so what we're going to do is we're going to pass it over to Andy. He has a little presentation. He's going to kind of walk through some examples of what might have happened, how we can have these issues with attack paths in Azure and in Intra, with respect to kind of what we're used to in the kind of Active Directory on-prem side. So,
Yeah.
Andy, I'm going to go ahead and pass it over to you. I'll share your screen.
All right, cool. Thanks, Jared. So, like Jared said, we're here to talk about this Microsoft breach and the brass tacks. I want to talk about like what happened, and if you're an Azure admin, what you should do to protect yourself potentially from a similar attack happening against your own Intra ID tenant or Azure environment. So, like Jared said, there's a little disclaimer. So, this is my quote unquote educated conjecture, which is a polite way to say my best guess, and my analysis, which is based on the information that Microsoft shared publicly. So I don't have any inside knowledge. I know what was said in Microsoft's blog post, and then from my own experience. So the facts as they are shared by Microsoft is you can find in this blog post right here. So they initially detected the attack on January 12th, 2024. They identified the threat actor as Midnight Blizzard, aka Nobelium, aka Cozy Bear, aka APT29, aka the actual thing it is, which is Russia's Foreign Intelligence Service, also known as SVR. The way that Microsoft initially identified this is they were doing regular reviews of their Exchange Web Services activity log, and then coupled that with their own knowledge of SVR's tactics. And Microsoft also said that they discovered evidence that SVR was targeting other organizations. So then we get into the actual tactics. Initial access was via a password spray attack, which compromised a quote unquote legacy non production test tenant. They gained that initial access in late November 2023. From that initial access, they used that access to compromise a legacy test OAuth application. So we're going to talk about what all these things mean. But let's just get the facts out of the way. This legacy OAuth application had, quote, elevated access to the Microsoft corporate environment. The actor created additional OAuth applications. They created a new user account. They created the above account in order to grant consent in the Microsoft corporate environment to the actor-controlled malicious OAuth applications. Finally, the actor used the legacy test OAuth application to grant themselves the full access as app role. And what I really want to encourage you to do as you're watching this video is hone in on this statement, because we are going to dissect exactly what this statement means, and what the impact of this statement actually is. And then they say the actor used these malicious OAuth applications to auth to Exchange Online and start collecting Microsoft corporate emails. Timeline view. So November, December, January. In late November is when initial access was achieved into this legacy non-production test tenant. And then on January 12th is when Microsoft states that they first detected the threat actor activities. In this video, we're going to focus on everything that happened in between, which we don't know exactly when any of these things happened. We might know the order that they happened in, but not necessarily. But in between these two times, these actions happened. So user creation, app consent, app role assignment, and email inbox access. So this is what we're going to focus on. And in particular, we're going to talk about the details about this and what this means. So to illustrate exactly what happened, I've got two environments set up. I've got Fabricam test tenant, and so this will represent our legacy test non-production tenant. And then we also have Fabricam prod tenant, and this will obviously represent the production tenant. I'm going to be switching back and forth between these and the deck, so I hope I don't make you motion sick. All right, we're going to visualize this attack path. So in the test intra ID tenant, the adversary gained access to a user through password guessing, and Microsoft's statement about what happened next is Midnight Blizzard leveraged their initial access to identify and compromise a legacy test OAuth application. So I interpret the word compromise in this sentence to mean that the user used some kind of existing privilege to add a credential to an existing app registration. And there are many, many different ways that that can happen. There are many different privileges that a user can have that let them do this. So they could have application administrator or cloud application administrator. And these could be scoped to the entire tenant, or they could be scoped specifically to this app. The user could have had directory synchronization accounts. It's not very likely. Could have been a global admin, hybrid identity admin. There may have been a custom role that Microsoft had created to enable this. Or the user may have been an explicit owner on the app registration. Or the user may have had not direct control, but they may have had an ability to give themselves control of the app. And two intro roles that allow for that are partner tier 2 support, which is a hidden role, and the privileged role administrator role. So in our Fabricam test tenant right here, on the left, if we go to app registrations, I've got the legacy test app right here. And so this is what Microsoft is referring to when they say legacy test OAuth application. They are talking about an app registration object that exists in a test intra ID tenant. Adding credentials to these things can be done in the GUI. So at certificates and secrets, you can add a new client secret. The user I'm running as is a global admin in here, so this user can do whatever. When we add that secret, we can see the full plain text value of the secret, which then we can use to authenticate using a client credential flow as the application, and then we can use whatever privileges the application has because we're running as the application. So let's move on. This is the next step. And so I want to pause real quick and I want to mention that an intra ID tenant, similar to an Active Directory forest, establishes a trust boundary. But because of the nature of OAuth, these trust boundaries are very frequently pierced through app registration to service principal relationships, like what we're going to talk about here. But otherwise, these trust boundaries mean that the boundary cannot be pierced without an administrator in the consenting tenant letting that happen or allowing that to happen. So this can't just happen out of nowhere. The configuration already had to be in place when Midnight Blizzard got here. So Microsoft's statement continues and it says, a legacy test OAuth application that had elevated access to the Microsoft corporate environment. What this most likely means is that this app registration had already been instantiated into the production tenant. And when that happens, the app registration is represented in the other tenant as a service principal. This service principal then is what the application is able to authenticate into this environment as. And so, whatever privileges this service principal has become the privileges that you are able to exercise by having the credential for this object and authenticating into this environment. Now, later on, there are certain privileged actions that Microsoft says the adversary took that most likely mean that the service principal already had either global administrator, partner tier 2 support, privileged role administrator, or it had one of these MS Graph app roles, app role assignment .readwrite.all, or role management .readwrite.directory. Let me stop here to show that in my test tenant, I've got my app registration. And then in my prod environment, to find the service principal that's associated with this app registration in prod, I go to Enterprise Applications and I find the application here. So Legacy Test App here. What you'll see is that the application ID is the same between these two different objects. So application ID here is starting with F585, etc. And that's the same as the app ID here for where the app registration lives. The object IDs are different because they are different objects. But this application ID is what connects the two together. So let me show you kind of the mechanics of how this works. So I have a commandlet in Bark called get msgraph token with client credentials. So this does the client credential OAuth flow to get a token that's scoped to msgraph. And you'll see that I am passing a client ID, which is the app ID. And then the client secret is the full plain text secret that I had created for the app earlier. And the tenant name is Fabricam prod tenant on Microsoft.com. So that's not this tenant. That is the prod tenant. That is this tenant right here. Now, the prod tenant has no knowledge of this secret. But because of the correlation from the app to the service principal by the app ID, I'm able to authenticate into this tenant as this service principal by using the app ID, the secret, and specifying the tenant that I want to authenticate into. So let me go ahead and do that. This is the resulting token that STS emitted back to us. And if we decode that token, we can see that the issuer is 785EA, etc. So that is going to be the tenant ID of the production tenant. And we can also see what privileges are associated with the token. And so under roles, we have the app roles that that the token has or the service principal has. And the one that we have listed is app role assignment .readwrite.all. So this token is valid for authentication into this environment. And because the service principal has been granted this privilege, we can do powerful things. We basically have the same power as a global administrator has, and I'll show how that actually works too. So I wanted to pause there and kind of explain this right here. But Jared, Jeff, Carlo, any questions so far? Anything I can clear up?
Nothing so far.
Okay, does this all make sense so far?
Yep.
All right.
Is there a way, potentially, maybe you'll get to this, is there a way for the attacker to easily validate that relationship between the legacy app in the test environment, test tenant, and the existence of the connection in the prod environment, assuming they don't have access to the prod environment?
That's a really good question, because that is something that I don't know. I don't know of a way where if I control this app registration, if I control this entire tenant, I don't know of a way to enumerate other tenants that have consented to this app. So I think a point to bring up here is that obviously Russian intelligence has like other intelligence gathering ability, outside of this technical system. Also, if they're targeting Microsoft, it's probably not hard to guess what Microsoft's actual tenant name would be. Like, you could try that, right? So maybe they just did that to test. I don't know. That's a really good question. The
Now,
opposite is easy, but figuring out from here, like where can I go from here? That's, as far as I know, I don't know how to do that.
If you're trying to audit the existence of this type of attack path, however, and let's say you're Microsoft or you have multiple tenants at your organization, you would have the ability to do that connection because you would just run the queries across both of your tenants or all of your tenants, and then you would see, hey, this app registration exists, the same GUID or whatever, the same app ID exists in both tenants, and therefore there's some connection there.
You can definitely do that if you have insight into both of them.
Yeah.
And also, if you only have insight into the prod tenant, you can find service principals that represent a foreign application, and
Gotcha.
and I'll show how to do that.
Cool. All right.
Yeah, good question. Okay, so let's continue on with the next step. And so Microsoft's statement here is the actor created additional malicious OAuth applications. They don't say if that happened in this test tenant or if it happened somewhere else. But for simplicity, we'll just say that these were created in the same test tenant. So what that means is that in, let's say, the test tenant is where they created those. We can come to app registrations and we can just create a new app registration. So like Andy's very cool app, we could say. And we'll say it's multi-tenant authentication. We don't really need to specify a redirect URI. And actually, yeah, I want to demo like how the consent process works for this. So we will say this, and we'll just leave this blank. So we'll register that application. So this application is created. It's not installed into any other tenant, but I will show like how that works later. We do need to make a little configuration here so that we can get the consent URL, which is here. But that's what that means, is they created these app registrations, which is a pretty low risk behavior, I think. Like if you're looking for something to like build an alert on or something like that, like this is pretty low risk, I think.
Can you just kind of expand on what you mean by low risk? Low risk of false positives, low risk as in it's not going to affect you much if an attacker creates a new app registration?
I guess it depends, because the ability to create an application is one thing, but the ability to give that application permissions is a totally different thing.
Mm.
So if you have like a lower privilege user that creates an application, they can't give that thing more privilege than they themselves already have. So
Gotcha.
I think it could be a good indicator that something's going on, but it's not gonna necessarily be like a high fidelity indicator that somebody is actually doing an attack.
Gotcha. Okay.
Yeah.
One thing I was going to ask too, just for those, I didn't mention this at the beginning, but Carlo, Jeff, and I are here to be the layman that ask Andy for clarification on anywhere where we don't understand it, which for me is a lot. Is there any actual like reason why I would want to use the or why I wouldn't want to use the portal as opposed to like some sort of API driven Python module or PowerShell module or whatever as an attacker? Like, I assume that all the logging and everything like that is going to be behind the API, and therefore it's kind of indifferent from a defender's perspective of whether you're using the portal itself or whether you're using like your PowerShell module.
Well, um, so there's two parts to answering that question. One is, as an attacker, there are certain actions that you would want to take, one of which I'm going to demonstrate later,
Mhm.
that you can't do in the portal, that you
Okay.
have to do through the API. And I guess the second thing is privileged actions can generate different activity logs in Intra. So, for example, with like promoting somebody to global admin,
Mhm.
that if you do that, if you do that as a service principal by accessing a certain API, it's going to create an event called like promote user to role outside PIM. But then if you do that just normally through the Azure portal GUI, it's going to create an event that's like promote user to role, and it won't
Mm.
say the thing about outside PIM.
Okay.
Um, so it depends. Like there are different events that are generated depending on how exactly you did the privileged action.
Gotcha. So that actually could be useful for using as a heuristic to understand how did somebody do this, because you may be an organization where people only use the web GUI, right? Or the, I don't know, the portal in
Yeah.
order to do this. And if somebody doesn't use the portal and we've tracked down what the different behaviors are between using the portal and not using the portal, then that may be an indicator that something's strange, even though it's the same literal activity. Sorry.
It could be. Yeah, it could be. Good question. Okay, so let's move on. Um, so the next action that Microsoft says the adversary took is they say they created a new user account, and I believe that happened in the production tenant. And uh, creating a user requires that a service principal has one of these intra ID roles: user administrator, directory writers, global administrator, partner tier 2 support, partner tier 1 support, or it needs to have one of these MS Graph app roles: directory.readwrite.all or user.readwrite.all. Now, remember earlier I said that I believe what this service principal already had was app role assignment.readwrite.all. This would allow the service principal to grant itself either of these app roles, but the opposite is not true. So with directory.readwrite.all, for example, you cannot grant app roles. You also cannot activate users into roles. You can't promote somebody to global admin with this. You can't put users into role eligible groups. This app role in particular, directory.readwrite.all, it gets a lot of attention because it sounds way more powerful than it actually is. But this app role is kind of equivalent in power to an intro role called groups administrator. So, um, the statement from Microsoft continues. So they say They created a new user account to grant consent in the Microsoft corporate environment to the actor-controlled malicious OAuth applications. So visually, this looks like the user visits a URL that is associated with this app registration, and they click, yes, I consent to this application. And in a default configuration, if the app is asking for permissions that do not require admin consent, what happens next is a service principal is created in this environment, which is associated with this app registration, similar to what I was talking about here. So the app registration gains the ability to authenticate into this environment with the privilege that the user was able to give it by, what the user could give by himself or herself or themselves, um, but no more. A user can't consent to more privilege than what they already have. So let's go back here. So we have Andy's very cool app, and we have the consent URL here. So I will copy this. And then in this other window, I'm logged in here as admin at Fabricam prod. So I'll open a new tab. I'll paste that URL. It's going to ask us to authenticate. And then this is just set up with like the base default permission that an app registration will ask for, which is being able to sign in and read this particular user's profile. And so we will say accept. This is very, very, very common tradecraft as well. It's like consent phishing. So it says, sorry, we can't sign you in. That's because I didn't specify a reply URL. However, in our prod tenant, if we go to enterprise applications now, we can see that there is a new service principal here called Andy's Very Cool App. And this service principal on the right has the same application ID as the app registration on the left. So that's what I mean when I say that the consent process results in the creation of a service principal, which is going to be associated with an app registration. Any questions about that?
Yeah, I have a question. So I guess when it gave basically the failure to the user,
Yeah.
so the permissions were not granted, or what was that failure exactly, and why did it still create the service principal?
So that failure happened after the service principal was created and after the permissions were granted to the service principal. So here's the service principal. And then if we look at permissions, we'll see that it has user.read in Microsoft Graph. So this is the permission that was being requested and that what the user hit yes on. The error came from the fact that in my configuration for the application, I don't have a reply URL.
Oh, right. Okay.
Or a redirect URI. And so what this is when the user logs in, they're going to get a token that the application is going to be able to use to impersonate, let's say, the user. And that token, it has to go somewhere. So like usually this would actually be like associated with like a web server somewhere. It's like actually running code associated with the application. And that web server needs to get access to that token in order to access the environment that the user consented them access into. But because I didn't have a reply URI, that's where the error came from. But the service principal was created and the permission is granted all the same. So let's move on. So things are changing when it comes to users being able to consent to things, but normal users have never been able to grant applications consent for the most dangerous permissions. Users consenting to applications, this is a foundational normal part of the OAuth architecture. Anybody who's an OAuth expert who looks at this is going to understand and know that this is happening all the time. This is how OAuth works. This is how SSO works in this world. So I bring that up because like some guidance you'll see will say like users just cannot consent to applications whatsoever. You could do that. That's going to create administrative overhead for IT. That they're gonna have to manually approve every application that a user wants to consent to. Maybe that is compliant with your risk tolerance. Maybe it's not. So that's going to have to be decided on an individual basis. What I will say is if that setting had been toggled to where a user can't consent to an application, it would not have stopped the SVR's ability to do what they did. So there are no silver bullets, and disabling users' ability to consent to applications is certainly not a silver bullet. It's yeah, I guess that's all I'll say about that. So the next thing is here, and the statement from Microsoft is the threat actor then used the legacy test OAuth application to grant them the Office 365 Exchange Online full access as app role. And the statement continues, which allows access to mailboxes. And then at the end of this, what you are left with is an ability to fetch email from any email inbox by authenticating into the prod tenant as one of these service principals, which have been granted a particular app role. Now, this is something that I really want to dig into the details about, because understanding how this works kind of leads you to one conclusion, which matters quite significantly, I would say. So here we are in our prod tenant, and what I want to talk about is this consent process. The statement from Microsoft is the threat actor used the legacy application to grant a particular app role. When you are running the Azure portal as a user and you want to do this, you want to grant an application an app role, the way you do that is you come to an app registration. Find your application that you want to grant an app role to. Let's say cool app 2. API permissions. Add a permission. And then we'll do the same one that's mentioned in the report. So Office 365 Exchange Online, application permission, full access as app. Now, when I click on this add permissions button, the portal is going to submit a request to add this permission to the application here, Cool App 2. So we'll click add permission. And it says it was added. Now, we need to look at a particular request. So we have post, payload. Okay, so I believe this is I think this is the request we want to look at. So this is the right request. And the request is being made to graph.windows.net/myorganization/get service principals by app IDs. Now, when you do this as a user initially, this goes into this state where the permission is listed here under configure permissions. So the permission is configured. However, it is not granted. So the permission is not effective until we come into here and we say grant admin consent for Fabricam prod tenant. Now, when I click on this and then click yes, so that hits this API called consent to app. This is a different API provider. This is the legacy Azure Active Directory Graph API at graph.windows.net. And the endpoint is my organization / consent to app. This API can only be accessed by a user. A service principal cannot access this API. And so the, let's say, contract that exists here is that a human being has to come in here and click this button in order for this app role to actually be effective. So this is not what the adversary did if my interpretation of this statement is correct. So in this statement, it says the threat actor used the legacy test OAuth application to grant them the Office 365 Exchange Online full access as app role. Now, the service principal itself can't use the portal to do that. It can't access the same APIs that a user can in the portal. But it can do this by accessing the MS Graph API endpoint, which is called app role assigned to. Let's see if we can find the right document. Yep. So the endpoint that a service principal hits to grant an app role is / service principals / the ID of the service principal / app role assigned to. Now, calling that API or making a post request to that API, the documentation here says that the app role that is required for the service principal to be able to do this is app role assignment.readwrite.all and application.read.all, or the combination of app role assignment.readwrite.all and directory.read.all. Those are probably the same for the beta version of the API as well. Yep, they are. However, this is not actually true. If a service principal has app role assignment.readwrite.all, it does not need application.read.all. It does not need directory.read.all in order to make a post request successfully to this endpoint. So this is why at the very beginning, or like the second step of our attack path that we were listing out here, this is why the level of privilege that this service principal had when later on it was used to grant an app role, at the bare minimum, what this service principal had is the app role assignment.readwrite.all msgraph app role. At a minimum, this is what it had. It could have been a global admin. It could have had partner tier 2 support. It could be privileged role admin. It could have had role management.readwrite.directory, but at a minimum, it must have had this. I want to say again that directory.readwrite.all is not enough to do this. Nothing else is. So this app role is unique in the fact that it, along with these intra ID roles, has the ability to bypass the human consent process when granting an app role to an application. And kind of what I'm hinting at, or kind of what I'm trying to say, is that the conclusion that I come to is that even though at the end result of the narrative, we're talking about the adversary having the ability to read all email inboxes, the reality, if my analysis is correct, is that this service principal had not only the ability to, let other applications read all email inboxes, but that it in fact had the equivalent of global administrator privilege in this tenant, meaning that it had complete unmitigated control of the entire tenant. So I want to say that, like, as plainly, as soberly as I can, is that my understanding of these systems and this statement about an application being used to grant an app role means that the adversary had complete and total control of the tenant. Any questions about that?
Yeah. Question for clarity. You mentioned the legacy Graph API and the new, I guess, MS Graph app role, or MS Graph API. Sorry. Would there have been any difference here, or can you explain? I guess, was there something that the legacy API allowed to happen that is not allowed to happen in the replacement Graph API, or I'm a little fuzzy on the details or what the difference is between the two.
Yeah, so the difference is that the legacy API is what the portal uses when you click on this button right here. That API cannot be accessed by service principals. And so that, whether it's a legacy API or not, like, the fact that the endpoint cannot be accessed by a service principal is what, let's say, guarantees that a person, a human being, has to come in here and actually click on this button. Whereas, there is a legitimate need for applications to be able to grant consent or to grant app roles without needing a human being involved, and that mechanism is expressed by this app role assignment.readwrite.all app role. So programmatically, if you want to do this, you have to use this role. Otherwise, you have to go in here as a person and click on this button right here. The other possibility is that this user that they created, they elevated this user's privilege to be able to grant admin consent. But in order to do that, this service principal would have needed either the global admin role, the privileged role administrator role, or the partner tier 2 support role. Those are the three roles that can promote other principals to global admin, for example. I don't think it's likely that the service principal had global admin. I think it's more likely that it had this app role assignment.readwrite.all app role. I don't know if that answers your question, Carlo.
Yeah, thank you.
I have a stupid question that steps back a few steps, I think.
Yeah.
It kind of seems like, if you go back to that diagram there, like when they added the app registration for the malicious apps, that's almost like foreign domain membership kind of rights, in the on-prem world. Is that an accurate look at that or no?
Yeah, I think so. I think it's a similar effect where you've got basically like you're bridging a trust, or you're like trusts are a funny thing in the cloud world because of OAuth. So like this kind of represents a trust, which is like kind of analogous to like a foreign security principal in an Active Directory domain. But I think a big difference is that the privileges that a foreign principal can have into a tenant are usually very, very, very low. And if they're very, very, very high, then that's a problem. That creates a lot of risk, for this environment here.
Makes sense.
I guess
Okay.
I have one more thing then. I guess what is your kind of overall assessment here of as an basically this as an organization like that uses Azure? Do I need to be concerned about this affecting my organization down the line, or is there? Obviously, this seems like it could translate to my own org if I was running an Azure tenant, and let's say I'm a managed service provider of some sort that manages many other organizations. This seems like the same attack path could be something that could be performed in my environment if I manage a lot of other environments. This is kind of what I'm getting at. But yeah, what should I be taking away from this as an organization that runs a tenant in Azure?
Yeah. So there's a lot going on here. The narrative touches on a lot of different actions that were taken, which each individually have their own corresponding security control or audit that you can perform. What I think Azure admins should prioritize is this piece right here. So if you're an Azure admin, you should immediately identify any service principals that have the most dangerous permissions in your tenant, and especially those service principals that are the instantiation of a foreign application into your tenant, because this creates a bridge from an outside source that you have no control of or insight into your environment. There are some free tools, free resources, free guidance that we are publishing that will help admins do this. So I don't think I'll go into the details necessarily because the details are pretty extensive. But we can link to a companion blog post that does go into those details. At a high level, you should identify service principals that have the most dangerous privileges in your intra tenant. You should remove those privileges where it is possible to do so. Where it's not possible to do so, you should understand the remaining risk that comes with allowing those highly privileged service principals to persist with the level of privilege that they continue to have. That first step, identify service principals with the most dangerous privileges. So that means any service principal that has been granted one of these intra ID roles: global admin, privileged role admin, partner tier 2 support, or a service principal that has one of these MS Graph app roles: role management.readwrite.directory or app role assignment.readwrite.all. Role management.readwrite.directory allows the principal to promote itself or anybody else to global administrator. App role assignment.readwrite.all allows the principal to grant itself or any other principal, service principal, role management.readwrite.directory, which allows escalation to global administrator. As an admin, there's nothing that I know of that allows an admin to control the mechanics of what I just said. When you are doing this, you will run into limitations of the Azure Portal GUI that will necessitate using a command line tool or some other tool to do this in a way that is efficient and repeatable. And efficiency and repeatability are what will create accuracy and you being able to actually action these things. As an example of the limitations of the Azure Portal GUI, you actually can't see this role in the GUI. These are a little bit easier to audit. These are simple to audit. Let me show you what the limitations look like for auditing this. So in my prod tenant, if I want to find service principals that have one of those two roles, I'll come to Enterprise Applications. I'll close these filters. And then I'll type the word graph to find the Microsoft Graph service principal. And then I need to open up the developer tools. And then click on users and groups. So this will list out principals that have some kind of role assignment against MS Graph, but it doesn't tell you what the actual role assigned is. So it tells you what the service principals are, but it doesn't tell you what they have. To see what they have, if you're going this route, you have to look at the request that came back. Got to find the right one. Here it is. So 3 entries, 3 objects, and what you're looking for is this field right here where it says ID. These IDs correlate to an MS Graph app role, but you have to look up what this GUID corresponds to. The blog post has details about what those correlations are. There are other resources that have that as well. But yeah, this is an example of like the limitations that Azure admins will run into if they're just using the portal GUI. I don't know of a better way to do this with just the portal GUI. If somebody does know of a better way, I definitely want to learn about that. So the second thing I had listed is that admins should remove privileges from those service principals where possible. You can actually use the intra ID activity log to understand what those service principals are doing. And then you may be able to cut down their permissions to only the permissions that are actually necessary for the application to continue to do what it's doing. I like the intra logs for this. So, for example, we have our legacy test app that we identified. And if we come down to audit logs, we can actually see what actions this principal is taking, what actions it's taking. And so, for example, here's where it says add member to role. And we'll be able to see, I used this earlier to promote something into the global reader role. You can see that it was used to add an app role assignment to another application. Now, what I wish I had is a list of, correlating these different events into what API was used to create these events, and what permissions are required to access those APIs. I don't have that mapping. I hope I can create it one day. I don't know if that mapping exists anywhere else. So you're going to have to look through these and kind of study and understand what level of privilege is actually required for any of these actions that you see here. So the last thing I had here is you're not going to be able to reduce privileges on every service principal, most likely. So you should understand what risk remains with allowing those service principals permissions to persist. What that means is that you should identify other principals that have control or can grant themselves control of those service principals. And you should also identify the systems that authenticate as that service principal or otherwise that authenticate using that service principal's credential material. So the example of a foreign application being able to authenticate into the tenant, you can find that by finding service principals where the app owner ID is different from your tenant ID. That will indicate that it is a foreign app registration associated with the service principal. But service principals can also be configured to authenticate via like OIDC. Their credentials may have been made accessible to some system somewhere, and that system has access to that credential. And then, of course, anybody who has admin rights on that machine can gain access to that credential. So that can quickly kind of spiral out of control. But something to highlight is that if you do, for example, have a service principal that like needs role management.readwrite.directory, what you should understand is that there are certain intro roles that allow quote unquote compromising that service principal. So obviously a global administrator is going to be able to do that. Global admins have full unmitigated control of everything in the tenant. But application administrator also allows that. Cloud application administrator also allows that. There are a few others, and then also some MS Graph app roles come into play as well. So service principal endpoint.readwrite.all allows adding credentials to any service principal. Now, all those details we also have in the blog post that we'll link like in the description of this or whatever. So I think we may be kind of coming to the end of what I have to present. I guess I'll go ahead and stop sharing my screen.
Cool.
Yeah.
Yeah, I think that was that was awesome. Especially the coolest thing is that a lot of times we hear about these breaches and we have very little actual like tangible information on what's going on. And I know that you gave the disclaimer that it's speculation that you're kind of doing, but I loved how you took what they said and you every time that you added an extra kind of like edge in your so-called graph, like you were able to explain the reason why I'm using this as conjecture is because of this is what this phrase says and this is how I'm interpreting it. And it really gave us a good look. But it's cool for those of us that see these types of breaches and don't actually know like how does this happen? What are all the different components? What's the difference between two tenants? What are app roles? What are app registrations? How do those connect? That's all really helpful for us to get an idea of, the danger that lurks behind the configurations that we're making, and then ultimately how can we try to avoid or discover those misconfigurations so that we can maybe avoid this type of situation in the future for our organizations.
Yeah, exactly. Yeah, I think it's a good opportunity. Like there's this very public, very impactful breach that just happened.
Yep.
With a lot of confusing terminology that people may not understand, which is not their fault. Like these systems are confusing and they're opaque. So I guess my hope is that explaining exactly how this happened and giving people free tools to like help find these attack paths themselves will do some good and help people out.
And that maybe the other takeaway that really hits me is if Microsoft is susceptible to this problem, then all of us probably are as well.
Yeah. There are legitimate applications that create these kind of attack paths, right?
Yep.
Like we've seen in some of our customer environments where maybe they have a third-party application that is doing just-in-time access for them. And so that's an application that's like promoting people to global admin, removing them from global admin, adding people to groups and stuff like that. And the mechanics of how that works is exactly what I laid out here. So that vendor, that provider of that service, of that application, if they get compromised, that could turn into compromise of your environment. So it's really important to understand that those are the facts. That's how these systems work. And sometimes push back on a vendor asking for super, super high levels of privilege that they don't actually need. Sometimes they do, sometimes they don't. And understanding the difference, I think, will empower admins to understand and improve their security posture.
Awesome. Yeah, well, thank you, Andy, for walking us through that. It was super informational. We're happy to keep the conversation going. So if people want to reach out and ask more questions, I think this is true. This was inspired by somebody reaching out and saying, "Hey, could you give us more context on what actually happened here?" So that's just the type of interaction that we're looking for, and we're happy to share whatever it is that we might be able to help to or provide to help people kind of get a grasp of what's going on out there. So cool. Alrighty. Thank you for your time, and hopefully we'll see you next time. Thanks again, Andy, and thanks Carlo and Jeff for joining us and being part of the peanut gallery with me. I think that was helpful to kind of get some of those questions answered. So thanks everybody, and we'll see you again next time.